Good morning, students. Welcome again to our Math Live Streaming Class 2020 or 2020. I am again Miss Edna, and I would like to tell you again that my office is in M.3 office of St. Peter Building. So let us recall the universal set. What is a universal set? Okay, a universal set is any set in consideration. If you're talking about real numbers, then it's about real numbers. If you're talking about integers, then it's all about integers. Okay, then if you have empty set, what is an empty set? An empty set is just a set without elements. That's why it's called empty, a set without elements or without any members. So that's it. So for finite set, what is a finite set? A finite set is any set which you can tell the number of elements or you can tell the cardinality. If I have a set of 1, 2, 3, 4, that's a finite set. You can count how many elements are there. 1, 2, 3, 4. So the cardinality is 4 or the cardinal number is 4. And for infinite set, it's the opposite of finite sets. Opposite. So infinite set, you cannot tell exactly how many members are there or how many elements in the set. For example, integers. The set of integers, it is the set of ellipses, comma, negative 3, negative 2, negative 1, 0, 1, 2, 3, comma, ellipses. So we cannot tell exactly the number of elements. Okay. Next is for our learning objectives for today. Students should identify whether the following pairs of sets are equal or not. And the second one, you should identify whether the following pairs of sets are equivalent or not. So our topic for today, students, is not that hard. It's easy. So we have to consider only if the sets are equal or not. And the second one is it equivalent or not? Alright, let's move on to the next one, which is, the topic is about the relationship between sets or the relation between sets. For the vocabulary, we have equal sets. What are equal sets? These sets are equal, the two sets are equal if they have exactly the same elements. So you have to take note of these words, exactly the same elements. So we write A is equal to B, read as A is equal to B, this one. If the sets are not equal, then we write A is not equal to B. Next is this. Equivalent sets. How about equivalent sets? What are equivalent sets? Okay, before I proceed, just write your number, like M.4/4, number 15, and your name in English like that. Okay, don't forget about it. So I might check your attendance and some comments later. So give me time to explain the meaning of the words and examples first. Okay, so again, welcome students to our math live streaming class. And math class starts at 9 o'clock and English class starts at 10 or maybe a little bit earlier than that. So be prepared. Yes, okay. Yeah, Tarik, are you okay? Kawina, I don't know what to do now. What is it? Is that your name? Okay, Kanapat, Nananan, you're there. Okay. So for equivalent sets, what are equivalent sets? So equivalent sets, two finite sets are equivalent if they have the same number of elements. So if the sets are having the same number of elements, meaning they have the same cardinal number. So we write A is equivalent to B to represent A is equivalent to B. Okay, it's this one. Examples, equal sets or not. Number one, so let's have this one with pictures. It's easier for you to understand. So what is it? You are asked to write the word equal or not. So on the left, you have set A. On the right, you have set B. This one here, we have A and, this is A and this is E. So you look at set A or A, you have apple. On B, you also have the apple. You have orange, um, strawberry, yeah, watermelon, and banana. So these are the fruits that you can find in the diagram on your screen. So you have set A and set E. The fruits, the picture of the fruits found in set A are also in B, in E, A and E. So they have exactly the same elements. So the word is exactly. So I'll write the word here. They have exactly the same elements. Okay, same fruits. What you can see on set A, in set A are also found in set E. So this number one, the answer for number one is this. Okay, equal. They are equal sets because they have exactly the same elements. Okay, it's easy, huh? Okay, number two, the same, right? Equal or not. A is the set of all x such that x is a letter in the word even, and B is the set of all x represents the letter in the word ever. So if we write in roster form, so let me change the color. So if we write in roster form, okay, A is equal to the set of the letter of the word even, so E, comma V, small letter, and then we have N, yeah? So we will not repeat the letter. So the cardinality is this one, N of A is equal to 3. How about B in roster form? B is the set of, okay, E. Next we have V, E, another E. We will write another E. And then we have R. So you see, N of B is equal to 3. The cardinality is 3. And if you compare the two sets, A and B students, you can see that in set A and B, they have E, the same letter, A, V, but the third letter on set A, in set A is N, and inside B, we have R. So number 2, what can you say about number 2 students? Okay, if you answer this, okay, not. They do not have exactly the same elements. They do not have exactly the same elements because of N and R. So what is the answer? Yeah, if you guess the answer, that's correct. Let's see. The answer should be not equal. Okay? So just write the word not. Alright. Number 3. Okay, C is the set of all x, represents the letter of the word net. D is the set of all x, represents the letter of the word 10. So what do we have here? So if you write in roster form, C is equal to the set of N, comma, E, comma, T. And how about D in roster form? D is the set of T, N, yeah, E, and also T. So what is the answer? Yeah, the answer is, Okay, equal. They are equal sets, or just write the word equal. Okay, let's move on to number 4. Yes, number 4. E is the set of all x, represents the letter in the word member, and F is a set of all x, such that x represents the letter in the word number. So let's have it in roster form. E is the set of members. So you have M, comma, E, M is already there, B, and we have R. Okay, M, E, B, R. Okay, how about F? F is the set of all number. Number is, we have N, U, M, B, E, R. So what can you say about number 4, students? Who can give the answer? Is it equal or not? Can you type down your answer so I can see if you can answer it correctly? Yeah, from any student can answer, so you can see it. Okay, I'll wait for your answer in a few seconds. Yes, give me the answer. Is it equal or not? Number 4. Yes, equal or not? Yes, Bombo is correct. Yes, songwriter. You're not giving the answer. No, not yet. Vero, what? That's the correct answer. Felix, Rocket. Yes. Rocket, just write the word not. Yes, it's okay. Sirapat, Skinny Focus. I remember Skinny Focus last week also. Yes. Tong Cup. Yes, the answer is correct. Tiramet. Yes, correct. Najun or Najuni, I don't know. Correct. And many more. Thank you for your answers. Yes, it's so easy, right? Yes, the answer is not. Okay, I cannot read all your answers. Yes, all of those answers are correct. Thank you. Okay, let's move on. Number 5, equal or not. Number 5, G is a set of 2, 4, 6. This is already in roster form. And H is the set of all x is a positive number and x is less than 10. Okay, so we can write first in roster forms. It's easy for you to find the answer. Is it equal or not? Okay, letter H. H is a set of, what are the positive numbers less than 10? Can you write down the comments, your answer below, so I can see if you know the positive numbers which are less than 10. Okay, let's see. Let's hear from M4/1 and M4/2 maybe. Okay, I'll wait for you in a few seconds. Yes, thank you for writing your name, class, and your number for your attendance. Yes, I hope everyone is here already. Yeah, God of Circle, that's your answer for number 4. It's correct. Flash Neo, correct. Bell 3A, yes. Bam, yes. Who is Bell of 3A? Are you from EP? Bam, not. Yeah, what is it? Bombo, your answer is the set of 1, 2, 3 ellipses 9. Correct. And the other one without the name. Yeah? Yes, yes. Tang, correct. Yeah? Yes, Rocket, correct also. You begin with 9, it's correct. Order does not matter. We know what, correct. Najun, correct. P is for pain, is correct. And many more. And salt. You have to add one more number after 2 to write it correctly. Flash nail, that's correct. So H is the set of 1, comma 2, and one more, salt, 3, comma, dot, or ellipsis, comma 9. So this is the answer in roster form. So you compare them, G and H. In G and H, you only have the elements 2, 4, 6. For H, you have the elements of 1, 2, 3 until 9. Are they equal or not? Do they have exactly the same elements? Of course, you can see from there, it's not. They don't have exactly the same elements, so just write not. Okay. Next is number 6. write equal or not. I is the set of 7, 14, 21 ellipses, 343, and j is the set of all x such that x is equal to 7n, where n is a natural number less than 50. So let's have first n. What is n? N is a natural number, so n belongs to the set of natural number or big letter N. So what are the natural numbers? Natural numbers, if you recall, are just counting numbers. How do we count, students? We begin with 1. So the set of natural numbers is equal to the set of 1, comma 2, comma 3, and many more ellipses and close. So set of counting numbers is the set of natural numbers. They are the same. But in this case, you have to find a natural number less than 50. And the other condition is this. This one, and let me erase this one so it's clearer. So this is the first one, and the second one is this. N must be a natural number less than 50. So you have to consider two things. X is equal to 7n, and n is a natural number. So what is it? So if you have it, so the n here, the small letter n, okay, let me erase this now. So this n here must be equal to a natural number less than 50. So it can be 1, your n is 1, can be 2, can be 3, or any counting number less than 50, so until 49, yes? So n is any natural number less than 50. So this is it now because it should be less than 50. This is only the one that I had a while ago is the set of counting numbers. So it's ellipses. We don't know what's the last one. But in this case, n is a natural number. It should be less than 50. So n is 1, 2, 3 until 49 only. Yeah? Okay, and substitute. So if it's 7n, x is equal to 7 times 1. Answer is 7. Another one, x is equal to 7 times 2, which is equal to 14. Yes? And I can have more here. Okay, it's here. Okay, and have here x, 7. And the last one, okay, times 49. 7 times 49 is 343. Yeah? So, we have 7 as element of set J, 14, and 7 times 3 is equal to 21, also 21, and 343. Correct? Yes? So, let me erase all of it. Okay, all of it are considered correct. So if you are asked to write the answer in roster form, okay, let me erase quickly. Okay, so J, so that's J is equal to the set of the first answer that we had is 7 times 1, which is 7. 7 times 2 is 14. 7 times 3 is 21. Ellipses. And the last one, 7 times 9, 7 times 49, I mean, is 343. Yeah? If you compare set I with set J, we have exactly the same elements. So if it's exactly the same elements, the answer would be the word equal. Yes? Okay, are you following me, students? I hope so. Yes, God of circle, correct, that's correct. Thank you for your answer. Flash nail, that's also correct. Let's move on to the next one. Okay, examples of equivalent sets. Okay, let me check the spelling. It should be equivalent, yeah? Equivalent sets or not. Okay, write equivalent set or not. Number 1, A is the set of all x, and here now, represents a letter in the word even. So we always write in roster form. If the given is in set builder form, it's easier for you to write the answer first in roster form. Or if you can answer right away, by just looking, then it's fine. So maybe I think you're a genius. So A, okay, is the set of, we have E, V, comma, N. No repetition of the same letter. So B, set B, capital letter B, is the set of, how about positive and integer less than 5? Can you tell me, students, all positive integers less than 5? Comment your answer down below. Let's see. Okay, I'll wait for your answer. Again, what are the positive integers? Okay, let me hide. Okay, this one, let me change it to, okay, I'll try this. Maybe yellow. Yeah. Okay. What are the positive integers less than 5? Yeah, that's the answer. Can you give me first the positive integers less than 5? Bombo, correct. Yes. Hirovich, correct. God of Circle, correct. Yeah. Okay. Flash Neo, correct. Yes, that's the answer. Najun or Najuni, I'm not sure of whether I'm saying your name correct or no. Okay, Panawich, correct. Yes, Tongkap, correct. Tarit, yeah, thank you. Yeah, Paim is correct. God of Circle, yeah. And MWH, Skinny Focus, Salt, correct. And many more. Chimpanzee, correct. Yes, so we have set of very good. Oh, let me change this. Okay, let me change to this one. So set of 1. Oh, okay, I'm just right. Okay, this one is 1, 2, 3, 4. These are the positive integers less than 5. So, in this case, you look, students, get the cardinality. N of A is 3. Here, N of B, the cardinality is 4. 1, 2, 3, 4. So 4. 1, 2, 3, 3. So if you say, okay, 3 and 4, they don't have the same number of elements. Both of them, they don't have the same number of elements. Set A and B, they don't have the same number of elements. So in this case, number 1, the answer is they are not equivalent, or just write the word not, because they don't have exactly the same number of elements. This is for equivalent sets. Okay, number 2, write equivalent or not. Okay, maybe you can also read the given set together with me so that you know how to read the set builder form, correctly. Okay, so if you are alone, or I don't know, with your friends or family members, maybe you can read them together so that you will know if you really know how to read the answer or the set in set builder form. Okay, let's start. C is the set of all x such that x is a letter of the word home. And letter D, or set D, is the set of all x such that x is a letter of the word house. Okay, so for our solutions, you can have C is the set of, in set builder form, you have H, small letter H, O, comma, M, E, close. And T, capital letter D, is the set of H, comma, O, U, S, E. So you get the cardinality. So N of C, how many members are there in the set? So it's 4. And N of 1, 2, 3, 4, 5 is 5. So N of D is equal to 5. Okay, this one is equal to 5. So if you look at the number of elements, or the cardinality, or the cardinal number, you will see that you get 4, and 5. So what is the answer for number 2? Yes, NWH. Yes, chimpanzee. Okay. The answer is not. Okay. Okay, let me see. Okay, this is not. N-O-T. Okay. Next, number 3. Write equivalent or not. E is the set of all x such that x is equal to 1 minus 1 over n, where n is a natural number. F is the set of 0, 1/2, 2/3, 3/4, 5 over 7. Okay, so let's go back to this. It's natural number. Natural number is simply a counting number. So we begin with 1, 2, 3, 4, and many more. So there are two conditions that you have to consider. This is the first one, this one, yeah, conditions that you have to consider. So let me erase the writings. Okay, yeah, okay, so it's clearer. So the first one is to write first the values of n. So for the values of n is equal to, again, 1 x must be equal to 1 minus 1 over n. And you just substitute the value of n. So if n is 1, so x is equal to 1 minus 1 over 1, which is 1 minus 1 is 0. And then if n is equal to 2, so x is equal to 1 minus 1 over 2. 1 minus 1/2 is equal to 1/2. So you have here E is the set of 0. Yeah, this ends. Oops. Let me go back to the slide. Okay, let me go back for a while, students. Let me find it. This is the exercise. Okay, I was able to. Okay, let me go back a few seconds. Okay, wait, which number are we now? This one here. Okay, okay, sorry for that. So we have 0, 0, and then 1/2. So you can write here 0, 1/2. Next, let me erase. I don't have a space here, so let me erase quickly. Okay, let's have, so it's clear on the right side. Okay, last few seconds, I'm done. Okay, and the other one is if n is equal to 3, so we have 1 minus 1 over n, which is 1/3 now. Okay, 1 minus 1/3 is equal to 2/3. It's 2/3 here, yeah. And if n is 4, 1 minus 1/4 is equal to 3 over 4. So you have here 3 over 4. Next you have 5 over 6, ellipses. Okay, that's it. So what do you notice about the two sets? They are both now in roster form, yeah? They are both in roster form, and we have the same number of elements, which we cannot really count because it goes until the biggest number. So if you notice, you see they begin with the same numbers: 0, 1/2, 2/3, 3/4, 5, 6, and so on. So number 3 is okay, and number 3 is called equivalent. So just write the word equivalent. Okay, number 4. Okay, G is the set of all x such that x is an integer and x squared is equal to 81. So write it. Okay, if you have x squared is equal to 81, yes, thank you, Rocket. Bam, that's correct. Flash, Pirovich. I'm sorry, I always do this. I was holding the right portion of the slide, so sorry for that again. My hand is busy on the right side of the screen, so let me go back one more. Okay, where is it now? I think think it's more up. Oh, this one. Okay, G. Okay, x squared is 81. So x is equal to positive, negative 9. So in roster form, G is a set of 9, comma, negative 9. It should be 9, comma, negative 9. Not only positive 9. Because 9 squared is 81. And also, quantity negative 9 squared is 81. So there are two elements of G. So if you look to this, okay, let me erase this one. If you can see there, the cardinality is equal to only 1. So it's clear that these two sets are considered not equivalent. So not. So just write the word not. And I'm okay with it. Not equivalent. Nanjun, correct? Yes, yes. God of circle, positive, negative 9. Panawich, not. Do you belong to, I don't know which class? Panawich, God of circle, and Najun. 3 of you are always active in commenting the answers. Yes, yes. Skinny focus also. Bam. Flash nail. Thank you for your answers. Okay. Oops. Now let me erase. Okay. Number 5. Okay, how about this one? Are these sets equal, equivalent, or not? So A is the set of all x such that x is a prime number, greater than 2 but less than 7. So maybe we'll have here now A in roster form, set A, capital letter A. So what are prime numbers? Before we answer, what is a prime number? Students, can you define what is a prime number? When you say prime number, when you were in grade 6, I think grade 6, you know the definition of prime number. Can you remember what is a prime number? Okay, kindly comment the answer below. Let's see. From from M4 slash 3 and 4, can you give me the answer? Yes. God of circle, you have 3 and 5 as prime numbers. Okay, so what is the definition of a prime number? How can you define? Bombo? Yes, you are also active. Bombo, am I correct in pronouncing your name? I hope so, Bombo. A number that has 1 and itself as a factor. Very good. Yes, that's correct. Panawich is the number that you cannot multiply. No, it's not. Sorry, no. It should be a number that only divisible by itself and 1. Tarit? Correct. Pirovich. That's the answer. Yes, Tarit and what's the other one? Bombo? Correct. So a prime number is a number with exactly 2 factors. What are the prime factors of 2? What are the factors of 2? 1 and 2, or 1 itself. How about 3? 3 is a prime number. What are the factors of 3? We have 1 and 3. How about 5? 1 and 5. 7. 1 and 7. 11. 7, 11. 11. What are the factors of 11? 1 and 11, and many more. So those are examples of prime numbers. They have exactly 2 different factors, 1 and itself. Okay, so x must be a prime number. Let's go back to A. X is a prime number greater than 2 but less than 7. So I saw the answer already from one of you, and it's from Pirouette. Yes, very good. Yes, that's the answer. Bombo, that's beauty. Bombu. Bombu. God of circle, that's the answer. Yes, yes, yes. So God of circle, we have, yes, the prime number greater than 2 but less than 7. Okay, the answer should be 3. Greater than 2, so it should be 3, comma 5. It should be less than 7. So it's, this is it. Only that. Okay, how about letter B? Can we read all together? B? Yeah? Okay, so that's correct. Thank you. Panalish, correct. Thank you for your answers, students. Yes, yes. 8 ways to win, correct? Yes, very good. Actually, we talk about your group, students, your group of M4 students this year. I think that most of you are responsible students and you really would like to pass your work. Yeah, okay, thank you for that kind of behavior. Yes, okay, let's move on. So B is the set of all x such that x is a prime factor of 15. This time, prime factor. What are the factors of 15? Okay, I'll write first. Okay, I'll write first some words. When we say factors of 15, what are the factors of 15? We have 1 from the smallest, 3, 5, 15. These are the factors of 15. But if you are asked to find the prime, only the prime factors of 15, only the factors which are prime. So what are the factors of 15 which are prime? Only what? 3 and 5. Yeah? Correct. Okay, that's it. So let's have it. Let's have the answer inside the braces in roster form. So what do we have here now? We have 3, comma 5. Yes? If you will get the cardinality or the cardinal number, n of A is 2 and n of B is equal to 2. So, again, go back. Edna, go back. One more. I touch again the right portion of this. Okay, where am I now? Okay, move. It's homework already. What's this? This one. Okay. Okay, be careful of not touching the right side of this iPad. Okay, what is it now, students? Okay, they have 2 as cardinal numbers. So we can say that these 2 sets are considered equivalent sets. Equivalent. Just write the word equivalence. Okay. Next, are they equal? So equivalent is checked. Yeah. So are they equal? At the same time, are they equal? Yes or no? Answer below. Are they equal sets? Not yeah, the homework will be later. Yes, you have homework. God of circle. Yes. Are they equivalent? Yes, they are equivalent. So, and are they also equal? Pirouette, correct. That's correct. They are equivalent sets and at the same time equal sets. Because if you recall, equal sets are sets which have this exactly the same elements. Again, equal sets are sets with with exactly the same elements. Apple, apple, orange, orange, like that. Watermelon and watermelon. They have exactly the same elements. Set of 1, 2, 3, set of 1, 2, 3. They have exactly the same elements as example. So A and B are equal sets. And at the same time, they are equivalent sets because they have the same number of elements, 2 and 2. Yeah? Actually, all equal sets are equivalent sets. Again, all equal sets are equivalent sets because you know equal sets exactly the same elements. If you have apple, orange, watermelon, apple, orange, watermelon, they have the same number of elements at the same time. 3 elements and 3 elements, or 3 members, 3 members. So this, in this example, so the answer should be 2, equal and equivalent. Yes? Okay. Next is this, the picture, which is easy to look. Okay, A. For set A, you have here, yes, This. Who likes apples? Who likes oranges? This is a strawberry. Who likes them? This. Okay. 1, 2, 3. 1, 2, 3, 4, 5. And here on the right side for set B, you have balls, different kinds of balls. This is for soccer. This is for basketball, for volleyball. This is a sports. I know, I forgot about this. This is for badminton. But it's not badminton. This is baseball or this one softball. Okay, so for A we have the fruits. For B you have the balls, any types of balls. So you have A and B. So are they equal? It's easy to look. Are they equal? Do they have exactly the same elements? If yes, the answer is equal. So are they equal, students? Yeah. Okay, are they equal? My question is, are they equal? Do they have exactly the same elements? A and B, do they have exactly the same elements? Yes or no? You're giving the answer now. Yeah. So are they equal or not? Yes. Bombu, that's correct. Not equal, but equivalent. Okay, they are not equal. Okay, but they are equivalent. Correct. So the answer is equivalent. Why are they equivalent, students? From M4/6 and 7. Well, yes, no. Rapipan? No, not equal. I hope that you mean like that. Yeah, no, for not equal. Yes. What is it? No, correct, Choyena. God of circle, not the same things, but have the same quantities. So meaning they are not equal. No, Boon. A lot of O. No, not equal. Yes, they are not equal, but they are equivalent. Okay, why are they equivalent? Let's count. 1, 2, 3, 4, 5. There are 5 fruits. 1, 2, 3, 4, 5. There are 5 balls. They have the same quantities, number of quantities. They have the same number of quantities, or they have the same number. So they are equivalent, just equivalent. Yeah? Is it clear? Yes or no? You can answer down below if it is clear. If you would like to ask more questions about this, you can approach me in my office. Again, my office is in M3 office. Okay, for your homework, students, you write your homework on A4 paper or students' line paper. Do not write on 1/2 sheet of your notebook's paper. Okay, let me hide. Where am I going to go? Here. Okay, do not print your homework. Please do not print your homework. You have to write down everything. And let me move a little bit so you can see. Do not print. I found out that some of you print some the questions and maybe you photocopied and write the answers on them. I would like you to copy. Okay, so this one, I would like to comment some classes. Okay, maybe we'll make it bigger. Okay. Oops. Okay, Math 4 classes. Number of students who submitted the work on time. Again, this number is only those who submitted the work on time, and I did not consider those who were able to pass the work late. So 4/1, 71% or 70.7% pass the work on time. Okay, for 4/2, 35 out of 57 students, so 61% or 61.4% specifically, so you are the third most responsible class. And 4/3, 30 submitted the work on time out of 44. I hope my number for the total number of students are correct. I base it from the list given to me in Yahoo in my email. So for 4/3, 68%, second most responsible class. So again, I'll clap my hands to 4/1, 4/2, and 4/3. 4/4 only 6, 4/5 only 5, 4/6 0, and 4/7 is 19 out of 34, which is 56%. Others may be submitted the work in the other office. Okay, for the rules, for neat work, okay, you consider this NATUS from 4/4. This is neat work. Yeah, so he followed everything that I told you, like name, class, number, the date, the score, exercise, and he copied everything which is I expected from you all the time, students. Yeah, so this is from Natos of class 4/4. For the neat work, yes, this is it, neat work. Yeah, and correct format, I consider the work of this. Correct format, yeah, Natos has the neat work, pyramids, you look at pyramids, okay, the correct format, yeah, I have here, his score is 9/10, empty or not, empty, the answer is empty, not empty, so it's easier for me to look and check, okay. This is it from Pyramid of class 4/1, number 12, and Natos, you have a neat work, and it's easy for me to check Natos of class 4/4, and once again, Pyramid of class 4/1. Okay. And please follow the following reminders. Starting 21st July, if you submit your work late, you will only get half of the full score. Again, one half only of the full score. If the full score is 10, you will get only 5. And why is it? You look, students, it is not fair. It's not fair to get a full score or a score higher than your classmates who always submit work on time. You will only take a photo of the answers. Their chance of getting a full score is lower because they submit the work on time. If Monday, and they don't know, they don't have that much time maybe to check their answers, so they just submit the work on time and their score is example 5 out of 10 or only 7 out of 10. While how about you always submit your work late, you submit your work on Wednesday, Thursday, Friday on the same week, you're late. So nowadays it's easier for you to copy, like you send the work in your line group, you take a photo, that's it. So it's unfair to those who always submit the work on time. So again, if you are late, you will only get half, starting 21st of July, half of the full score. So I hope that you understand this rule. Okay? So why one half of the full score? We have what is the reason for this? So if you arrive in school late, absent during class hour is again half of the full score. Headache, stomach ache, heartache, and so on. If you visit places with your family around Thailand or abroad, if you have practice in or out of school, please be responsible, submit your work on time. If you send your work in the wrong office, so that is not my fault, it's yours. You have to know my office. So if you want students a good score, then please pass your work on time. Yeah? So always be responsible, because a responsible student, if you are responsible later in life, you will also become a responsible maybe father, mother, or a responsible citizen. So this is it. Submission is on Monday, every Monday. But this Monday is a holiday. So you can submit tomorrow if you will be here tomorrow, or until Wednesday, because Monday, Tuesday is a holiday. So you can submit until Wednesday, 9 a.m. Yeah? Okay. So this is your exercise. And you have to copy everything. Where is it now? It's gone. Okay, let me find it. Wait. Sorry. It's gone, Mr. David. Okay, sorry for that. Can you open the file because they will take it. Okay, thank you. Okay. Could you please take screenshot of your homework, and we're done. Okay, where is it now? 1 minute. Okay. The last one, the homework. Where? Okay, please take a photo of this, your homework, students, or a screenshot, and you have to copy everything on the A4 paper and do not print. Write only the word equal or not. Okay. Next is this. Number 2 and 3. Copy again. And answer. Do not print 4 and 5. Yeah. Okay. And the last, number 6 and 7. Okay, that's it. So, equal sets are just sets which have exactly the same elements, and equivalent sets are sets with the same number of elements. So again, always be responsible, and thank you for joining, students. I hope to see you around next online class, and keep safe, everyone. Please don't forget to like this video, or you can rewatch this video. I hope that you have a good day. Goodbye for now. See you.